So in this segment, we look at one last type of combinational circuit called the encoder. The encoder is basically the opposite of decoder. So in a decoder, you get n inputs and provide 2 power n outputs. Here the exact opposite happens. We take 2 power n inputs and provide n outputs. For example, let's take a case where we have 8 inputs. 8 is 2 power 3. So we will have 3 outputs. So the inputs, let's call them D0, D1, so on up to D7. And let's say the outputs are X, Y, Z. Now in an encoder, ideally at any given point in time, at most one of the inputs can be equal to 1 and all others must be equal to 0. So assuming that is how the, assuming that rule is always followed, meaning at any given time we do not have 2 or more inputs set to 1. At any given time, at most one input is equal to 1. Here's how the encoder works. Corresponding to that input line which is set to 1, you will get the output. Meaning, if your D0 is 1 and all others are 0, your output will be 0, 0, 0. If your D5 is 1 and all others are 0, corresponding to 5, your output will be 1, 0, 1. If your D4 is a 1 and all others are 0, for example, your outputs will be 1, 0, 0 and so on. This is assuming at any given point only one of my inputs at most is equal to 1 and all others are 0. But we cannot always assume that will be the case, right? So for some reason, let's say by mistake, someone turns 2 input lines on at the same time. Then what happens? For example, let's say D3 and D6 both have been switched on by mistake. For D3, the corresponding output should be 0, 1, 1. And for D6, it should be 1, 1, 0. So your final output, if both of these are on, becomes 1, 1, 1. Meaning, whichever of the variables should be 1 because of this and whichever should be because of this, all of them become a 1. So here we get 1, 1, 1. But we know 1, 1, 1 should be corresponding to D7 and D7 is not even equal to 1 in this case. So that's creating an error, right? So we need to do something to fix how the encoder works in case more than one input gets switched on at the same time. So for that we use something called the priority encoder. So what we do here is, apart from our usual output bits, we add one additional bit called V, which stands for the valid bit. So this valid bit indicates whether only one input is switched on at a time or there are multiple inputs switched on. So if more than one inputs are high at the time, then we set V equals 1 and reflect the output corresponding to the highest input line. Meaning, let's say like we saw earlier, D3 and D6 are both equal to 1. Then we set V equals 1. I'm sorry, this should be V equals 1. We set V equals 1 and then which of the 2 is higher? Between 3 and 6, we know 6 is higher. So we ignore the fact that D3 is high and we consider D6 and reflect the output corresponding to D6. That is what we do. So let's say my D4 and D7 are high. Then I set my valid bit to 1. I ignore the fact that D4 is high and corresponding to D7 my output should be a 111. So that is what gets reflected in my circuit. So this is the truth table for the decoder. So when all my 4 inputs are off, my valid bit is off to indicate that everything is low. None of them is a 1. So irrespective of what X and what Y I get there, the fact that my valid bit is 0 indicates that all my inputs are a 0. Now when one of my inputs is a 1, immediately the valid bit becomes a 1. One or more of the inputs. So what we do here is, my D0 is 1 and all others are 0. Then corresponding to D0, my output should be 0, 0, which is perfect. Now if my D1 is a 1, irrespective of whether D0 is a 0 or a 1, I am going to reflect D1 because among these two, this one is the higher, provided these two are 0, which is why I have a don't care here. So given that my D2 and D3 are 0, whether my D0 is a 0 or a 1, what I am going to reflect ultimately is D1. So my output will be 0 and 1. Similarly, given that D3 is a 0, among these 3 I am only going to reflect D2 irrespective of what value these two take. So these two are don't cares. For D2 taking a 1 and D3 taking a 0, it's 1, 0. Similarly, here it is 1, 1. So this is the truth table for an encoder. I would invite you to pause the video here and try using Karnaugh maps to derive an expression for x in terms of d0, d1, d2, d3, one expression for y and one expression for b. So when you derive, these are the expressions you will get. So that is a quick overview of encoder. We have 2 power n inputs and n outputs. Ideally, only one of the inputs should be high at a time, and the output is corresponding to the binary equivalent of that input. But in case you have 2 or more inputs on at once, an error might be created. So we set something called the valid bit, and then we reflect the highest input which is on as the output, meaning if I have D3 and D6, D6 is the higher of the two, so I reflect D6 in my output, ignoring the fact that D3 is also on.